Hello everyone! So I have been trying the Kolors virtual try-ons for the last few weeks. Other than the AI video stuff, I have played around with the e-commerce workflow. Something that's related to work, and I see these are very trending, is keeping up with the trend in Hugging Face of this Kolors virtual try-on demo where you can try various images and use different garment clothing to do virtual try-ons with virtual models. Here, you're also able to upload your own image for virtual try-on as well. Previously, I did some examples such as this one and some other examples like this one that I have posted in Patreon groups, and I believe many Patreon members have also seen these field results that I did using a very fundamental technique, basically using Kolors to replicate the virtual try-on workflows in Hugging Face. Based on the paper in Kolors, what I have seen is that their IP adapter is very strong. I remember the IP Adapter Plus custom node creator Matteo talking about this IP adapter before, mentioning it's very strong. You don't need to use very high strength number settings in the ComfyUI custom nodes in order to create styles similar to the reference image. What I see is that when the Kuaishu company created the Kling AI, they had the virtual try-on API service. Of course, this is the same company doing the Kolors, and their paper from the Hugging Face space here. You can see the Kolors IP adapter plus models where there are a lot of hints that you can see they are using these IP adapters for the virtual try-on that is also relevant to their research paper here. There are some hints about that as well. So I did that in and created some very basic workflows. 2 weeks ago, I did this and it's okay. It doesn't have auto masking for the outfit, and we place that manually in ComfyUI, but we can use the Kolors models, diffusion models, also the control net if necessary, and of course the IP adapter of Kolors, where we can replicate almost the same virtual try-ons in the Hugging Face demo page here. As you can see, there are many different poses of the virtual try-on model where it's in different positions, different angles of the person, and is also able to replicate the clothing that's put onto the mask area as well. So in this video, I will go through my workflow creation. It's not very complex. It's also very fundamental basic stuff, using what is available in the Kolors Hugging Face page here, whatever models they have, and trying to replicate what they have in their commercial APIs for virtual try-on. What I did is very similar to what they do in the virtual try-on page. And here, as you can see, I just generated another example. Although some details are missing or not correct even in the Kolors virtual try-on, which, as you can see, this dress is not a straight line of the white color where you see the output of the virtual try-on model is wearing another white dress on the bottom, which is something that's not going to be perfect as well because, well, in the Kolors IP Adapter Plus models page here, they have mentioned that the overall satisfaction here is above the SDXL IP adapter and also the mid-journey one, which costs a very high style transfer using this IP adapter models, but is not going to be 100% exactly the same clothing as what we have for the garment image. So that is okay, I guess, if people want to base it on this model and fine-tune it. If you have your own clothing outfit and use additional training or on top of that, embed some weights, then you can fine-tune these models that will be able to put a higher percentage of more accurate virtual try-on generated results. But mostly, so far in my tests with the Kolors IP Adapter Plus with the Kolors diffusion models, they are able to hit about 70 or 80% accuracy in the generated results. So let's go through the workflow here. Again, this is just like the basic concept of IP adapters where you have your image for image to image here, where you load the character image, for example, your own photos or other models' photos for virtual try-on, and you have an IP adapter here again using the Kolors IP Adapter Plus and also the Kolors Clip Visions and all this. I will provide the links in the description below where you can go to Hugging Face and download those files. So the Kolors IP adapter is actually using the IP adapter plus custom nodes that we used to run and apply for stable diffusion as well. But all you have to do is load the models. You have to load the Kolors IP adapter models and also the Clip Vision using the Kolors Clip Vision model. Then you pass the image to the IP adapter advanced where you load the image here for passing that image data. Also, we are using the weights here. I try with 0.7, which is going to give the most stable output result. Sometimes I will try higher numbers here, maybe 0.8 or 0.9, and the weights type. I have tested that so far. The strong style transfer can generate similar results to what they did in this Hugging Face demo page where they have different angles like this one with the face facing to the right side. And then I did totally another style of clothing, such as this shirt with the tie, and I'm able to replicate something like that workflow here. Then the next thing is I'm using Florence 2 to generate the text prompts from my image, where I pass the IPAdapter image for the text prompt generation. So it's able to enhance what is going to be generated in the diffusion model when it comes to encoding those noises doing sampling. It's able to understand what we need in this specific try-on in the masked regions for the virtual try-on. And before that, talking about the masking area, I have set up two methods for that right now. Previously, when I tried the demos 2 weeks ago, I was doing the masking manually in the load image using the mask editor. And right now, it's semi-automatic. We are able to use the segmentations through segment anything and blurring those masks and put that into mask regions for the try-on clothing as the generated result. But I have put a switch here in case some clothing, like for example this one, is okay to use segment anything to generate. But sometimes if you have different clothing like this one, the tank top or a long dress, and the shirt with a tie is totally different shape with this masking long dress, then that won't be able to do something using segment anything after you mask the tank top or the dress, and you have the other areas on the arms that you need to mask for this long sleeve shirt. So in that case, you have to do manual masking like what I did in the previous examples here. So the switch here using the segmentation, if you turn that to true, then that will use the segment anything modules here. Well, this segment anything I have used a lot before in previous videos, in Animate Diff, in Mimic Motions, all kinds of AI animations to selectively mask an object in each image frame, and now put that into the auto masking for the image in this case. So we can use the auto masking like that. Or if we turn it off, let's say I want to use manual masking. So here I keep the note to remind people. So in this case, this is a long sleeve sweater, and I can change the same types of clothing in which the garment here is a long sleeve sweater as well. So it's able to do auto segmentations in this case. But sometimes if you have a t-shirt on the character and you have a long sleeve sweater as the garment, then you might need to use manual masking using the mask editor to do that in ComfyUI. And for the auto masking here, I have put the segment prompts. So here I ask the question, what to segment. These strings are actually coming from the segment anything custom nodes. I saw lots of people have missed this prompt when they're using segment anything. They just leave this empty. So you have to use that in order to selectively segment the objects. So right here, I put this prompt and connect this into here and highlight this as a green color. So you know visually you will see this is going to input something. Just a reminder for you guys, and that's all you need to input the two images and whether you want to use auto segment or not. And if you are not using auto segment in this case, I would try one time. So right-click your mouse and go to Mask Editor, and here you are able to do masking. You don't have to be exactly the same shape, but just kind of around that area, and the best way is to leave a little bit more space. Enable the diffusion model to do some sampling, smoothen the side areas here. Once you have that, it's able to do the masking with this. In this case, I'm not going to use the red sweater because this character has a red colored dress, so I'm going to change the other sweater color. Let's say I have a black long sleeve shirt here. I am able to do that with this character and disable the auto segment. It will pass the image data and the mask data from the load image node to the switch here, passing lastly to the color samplings where we are doing all the heavy loading in order to generate the virtual try-on image. Let's try these examples now. Here we got the first result, and as you can see, it's very close to what we have from the image that I input. Let's drag it down here so we can see it more closely. So there's the load image for the character, here's the garment that I input, and here's the result with the black dress. The black long sleeve shirt going on the woman's model, fitting on the newly generated image. As you can see, the Kolors IP adapter and the diffusion model are quite smart. In this way, it's able to roll up the sleeves in some cases where, as you can see, I haven't fully masked the front arm here. When the IP adapter sees that the style of the long sleeve is longer than what I have in the masking area, it will pull up the sleeve a little bit like this style. So yes, that is how to use this virtual try-on. Let's try out other styles where I have different types of clothing as input for the generated image. Okay, so for example, I have another virtual try-on image model here and I want to switch to other types of sweaters. That will be masking this area where we can use auto masking because it's the same type of long sleeve. But if you're using, for example, the tank top here, then it will be easier to use manual masking with the mask editor ourselves. But sometimes it works with auto masking using segment anything. So let's try segment anything once. It won't always have the same good result. So I would suggest for the kind sampler here, just keep it random and try a few more times to get a good result. Okay, so here are bad examples, but it's good to show the bad examples of how this is not going to work well. Using auto segments sometimes isn't going to look pretty. As you can see, because we're using auto segments and the tank top here, it cannot mask really nicely. Although the shirt can be tucked into the pants and so on, in this part, it's exactly not what we expected for the neck and shoulder part. But then, if we are turning off the segmentations for different types, what I mean by that is that you have a long sleeve shirt and a tank top which have different shapes in terms of masking. So when we're using the masking here, where we do the masking like this, we will have a different shape rather than using the tank top masking shape, right? So sometimes I find that using the mask editor in the load image will perform better than just auto masking. That's just how it is. And sometimes, even in Kolors' Hugging Face demo page, I find that they have similar issues as well. But this diffusion model and their IP adapter are currently open source, performing the best in virtual try-on and being lightweight, well, lighter weight than other virtual try-on frameworks that we have. And this is the second result which, as you can see, is looking better. At least we have the short sleeve cut off and showing the shoulders as expected in the tank top area here, but we still have to generate a few more times to see if there's a good result for that. For example, this generation is getting close to the input image. What we can improve is that we can do some text prompting here. So other than the forms to generate text, I also do our combined prompts here where you can do your manual text prompt. So I added multicolor tank top in the text prompt here just to enhance what we want in the generated result. Using this virtual try-on with the Kolors models and their IP adapter, I find that it also happens like the previous examples. I'm using this image and this dress that's going to cut off this part using a white dress, where this sometimes happens even in the workflow as well. So I want to show something that it cannot do and something that you can do using these models. For example, here if you're using different types of clothing, it won't be able to do the try-on. Like this one, this is like a one-piece long dress. And this is the shoulder strap on the side here where you expect that to be on the shoulder. But if you're just using auto segment anything with the auto masking method, then it won't be able to do that with different types of clothing. But if you're using this dress manually with the mask editor, of course you'll be able to mask the whole body of these models and then fit the whole clothes, this one-piece long dress, on the model. But that's just how it works with AI. We have to understand the types of clothing and what's right to input in order to make it look better. So in this example, if you have the same types of clothes, long sleeve shirt with a long sleeve shirt, then you'll be able to use the auto masking with segment anything and produce some normal virtual try-on images. So let's try this example and you'll see what I mean by that. Here's the generated result that looks closely like what it is in the input image, where you have the black color zip on the hoodie, and there's a zipper that's black color as well. The IP adapter here is able to read those elements in the input image, but sometimes it's not going to be the same because of the shape from the original source image. Where you have the rolled up sleeve like the character here, sometimes I would say we have to generate a few times to get one right, honestly, because it won't be able to use just an IP adapter and replicate something exactly the same as this image. It's not like copying and pasting on top of that, because this AI is going to be running some sampling steps, going through sampling, and it will sometimes look a little different. And what we can do is something that's able to replicate closely 70% or 80% of what is actually the actual image of the clothing. And like here, while I'm talking, I generated a few of these images, and some don't look like the image from here, so we have to just keep testing it. Sometimes we have to configure it on the top here, so maybe try another scheduler to test. Maybe we can try out the other CFG as well. that is also affecting the output. And also in the, let's say the IP adapter here, sometimes if you set the weights up here stronger or less, it will also affect how it looks in the generated results. So yeah, like this one is very close to what it is of the green color sweater or the hoodie. It's able to produce the unshifted styles using this hoodie on this AI character. And the easiest way, or I should say the way to get the best result, is transforming the same types of outfit. For example, like this one, a white long sleeve shirt or sweater. Then you'll find something like long sleeve shirts like this are also workable for the character here. So let's generate using this image and you'll see how that's going to happen. So in this case, if I'm using segment anything to auto mask the regions of the shirt, it's always getting some weird results. As you can see, it cannot replicate the same colorful shirt like this on top of the AI character, where in this case, if you generate a few times, you see some weird output. Then of course, obviously you'll be using manual masking for what's in the image, and here we're going to mask the area of the long sleeve hand as well. Leave more space for the AI to get some creativity, and this way, it will have a higher percentage of getting a better result, almost close to what we have in this clothing. So for examples like that, we have almost the same outfit styles and clothing put on the try-on of the AI character image. And I saw their virtual try-on like this one, for example. It is also sometimes getting some weird results if you're using different shapes of clothing. They have to enforce some different masking techniques to do that. Yeah, that's just the way it is currently with what we have in the technologies, using segment anything or any other kinds of auto masking. If we can use something like segment anything to mask the whole body area, but sometimes it will miss out the long arms, the front arms part of the image, then it won't be able to produce more accurately like this. So yes, sometimes we have to do it manually, and you'll see there's a better result like this one, more accurate or close to what we have in the original source image. And sometimes like this again, even in Kolors Hugging Face page, you see this one-piece shoulderless dress where the output image, as you can see, looks different in the bottom part of the white dress. That is something that it won't be able to replicate for the try-on clothing. But these models are so far in the open source space, what we have right now, with the highest percentage we can get for virtual try-on. And I think these are able to do for clothing demos, for e-commerce, whatever. But you have to generate a few more times to get a good result. You can't just generate every image batch generation for all your catalog and hope that every generated result is 100% right. And even for other AI-generated images, it won't happen like that too. So that's the conclusion of using the IP adapter plus Kolors to generate virtual try-on results like this. And also these examples like this shirt, it's able to do something like that very close to what it is. But sometimes it's not 100% right. So I have another example where I'm using this same input clothing where I can use that for different people's body shapes as well. Fatter or skinnier people, or tall or short, it's able to use manual masking and perform better. For example, like this one, the virtual AI girl, and this is a tank top. And obviously, it is totally different types of clothing. What we'll have to do in this case, using this workflow, is that I'm going to use the manual masking area. So let in more space on the side here, where we have more area for the AI to generate the shirt that we have. And sometimes we have this masking space that is able to allow the AI to get better generated results. So sometimes with the same types of clothing, if you have like this AI girl, that we have a tank top and other tank top, you can do auto masking. But if you have different types of clothing, like in this case, you will have to use manual masking in ComfyUI. So for example, here's the result that I have. And yeah, this is the generated result, almost the same as that the shirt is tucked in because we have this original image where it doesn't have a lot of space. A lot of space for the shirt flapping out, that's normal, but so far this is the closest result in the open source world, using an IP adapter to replicate for virtual try-on. And it's able to produce something very close to what we have for the virtual try-on expected result. So for example, like this kind of scenario where we have the same types of clothing, you have the source image of the character wearing the tank top, where you have the garment which is also the tank top. Then in this way, you are able to segment anything and do an expand mask. Just expand that mask a little bit. And also remember to put the prompt here mentioning you want to target the tank top, turn that on for segmentations, and that is going to be able to be used for auto-generate in just one shot. But then this pipeline is used for different styles of the same types of clothing. For example, if you have one type or one model of tank top and you've got different colors like blue or yellow, etc., then you can put that into a pipeline loading multiple images and generate that in ComfyUI. Then that will be the concept of using these same types of clothing for virtual try-ons. But other than that, like the previous examples or other examples I have where we have different types of clothing, then we have to do the manual masking on the mask editor to highlight the regions where we want the result to appear, which is the clothes to try on the generated image. Like for example, other examples like this one, we have the same types of clothing, which is a long sleeve sweater, shirt, etc. The same shape of form where we can use the auto segmentations. And here in the prompt area, we type shirt, and that is going to be fine. And the next step is pressing the Q prompt and running the generations. So as you can see here, the generated result is a V-neck red-colored sweater or shirt where you have the same types of output in the generated result. But again, it's always going to follow the original source image where the character is rolling up the sleeve. That is going to follow the same styles. So if you want to show the long sleeve display of this product or clothing, then you will have to manually highlight those areas using the mask editor to do that. So just like these examples here again, we have the clothing try-on, and you see the shape is also following what we have in the original source image where the sleeve is rolled up. And this is due to the segmentations only masking this area for our try-on clothing to put on top of that and do an in-painting like feature. And that way it's not going to be allowed or able to use a long sleeve to totally cover the arms or the front arms like that way. And also, for example, like this one, as in my previous examples, I have the same types of clothing where this is the same kind of dress but looks a little different, where I can just use segment anything using the auto masking method to generate this image. So yeah, that is almost what I want to cover for the Kolors using the IP adapter and image-to-image masking in painting method to do the virtual try-on that we can replicate like what it has in the Kolors virtual try-on hugging face page, although that will be slightly different. For example, like this dress here, if we have a simple pattern like this sky blue color dress, we have the same types of dress in the source character image, then that will be a very easy way for the AI to do a virtual try-on for our generated image. But sometimes, like for example, if you have different types or different shapes of clothing with the character image, then that will be kind of difficult. I can't say it's not possible. But even in the Kolors hugging face page, as you have seen in some demos before, it's not always going to show the best result in a virtual try-on like this. Yeah. So as a conclusion, these AI models are doing, so far as I can see, the highest percentage success rate as an open source model to run a virtual try-on workflow. And this workflow is going to be available to download for everyone free. You have these basic features to run the virtual try-on. And for my Patreon supporters, you're going to have the other additional features using Flux to enhance the detail and restore the face. And then you have upscalers. And I will add something more in the second version to make this more detailed and of better quality. So yeah, that's it for this video. Hope you guys understand that I'm showing something that's workable and something that's also not workable, some bad examples. So you guys don't have to guess while testing and trying out, having a lot of, question marks in your brain where something I tested out already is not working. I will show that in the videos. And you guys know that, you don't have to go through those hard paths for the wrong stuff. And something is working, for example, like this one, then I show that the success rate is higher, and sometimes it will not be working for certain types of clothing as well. So you guys have to understand the concept of that and, just make it work better. So that's it for this video, and I will see you guys on the next one. Have a nice day. See ya.